right, now we're going to talk about phase changes. Phase changes, you all know, solid to liquid is melting. Liquid to solid is freezing. Liquid to gas is vaporization. Gas to liquid is condensation. Solid to gas, which is what carbon dioxide does, is called sublimation. And when you have a gas that skips condensing and goes directly to a solid, we call that deposition. All right. The example of that last one would be when you come out in the morning and you find frost on your car. It's a cold morning, but it's still fairly humid, and you get frost on your car. It probably did not become a liquid and then become a solid. It went directly from a gas to a solid. So that's deposition. Now, we've already talked about phase changes when we talked about heat, and we talked about the fact that if you're adding energy, so we're going to add energy into this guy, no, I lied. Into this guy, and this guy. In all those cases, adding energy helps move the particles more, and they become a new phase. And if you remove the energy, which are the ones I didn't highlight, those are also going to have a phase change. Well, we're not taking into consideration pressure in this case. All right? When we take pressure into consideration, we get a diagram that looks like this. Now, we've got, for water, this is a curve between solid and gas, and this is a universal graph. If you get a graph that looks like this is going to be the solid, this is going to be liquid, this is going to be the gas. Excuse me, even if it's not layered. Now, the lines may be that line may go this, that line may go that way, that line could be that way, this line could be that way. They're going to be different shapes. But in a diagram where pressure's going up and you have temperature increasing, the top left-hand side is going to be solid, the bottom is going to be gas, the top right is going to be liquid. Okay? You'll notice that 760 torr is 1 atmosphere. We've learned that. At 1 atmosphere, if we follow this line across, when we come into contact with this point between a solid and a liquid with water, it's the temperature 0, which is the melting point of water. As we further along on 1 atmosphere, we come to this point, which is the boiling point of water. So under general conditions, you're going to find the 1 atmosphere line, and that's going to tell you the general boiling and freezing points. But what if we had our pressure cut in half? And this isn't to scale. But let's say this is a 0.5 atmospheres. As we follow across, we encounter this line, the line between solid and gas, and that's at a temperature below 0. All right? So in that case, you wouldn't have liquid water form. It would just go from a solid to a gas. So a low pressure means you've got that particles can move fairly easily, and it's easy for them to escape, and so they can go directly from a solid to a gas. And at this point, if we were at, let's say this is 2 atmospheres, and we go across, we find that our boiling point, or our melting point, is still close to 0. It's a little below. But in order to get that to become a gas, we're probably not going to get it because it's going to get to a point where we call the critical point, where that liquid's now going to act like a superfluid. Okay? Notice this guy here, the triple point. That is the temperature at which, and pressure, at which you get water in solid, liquid, and gas form to exist at the same, all those phases together. And that's going to be an atmosphere of less than 1 at just slightly over 0 degrees Celsius. There, if we were at school, we would do this experiment. We're not, but I'm going to show it to you anyway.
Okay?
But you just said it doesn't happen.
It doesn't happen at atmospheric pressure.
Okay.
So we're going to increase the pressure a bit. First thing we're going to do is make tiny little pieces of dry ice. And we need tiny pieces because what we're going to do is we're going to try to shoehorn them into these little pipettes that I've cut the tips off of.
All right.
So we're going to just try to like do this, like use your and try to like drop it down into the bottom.
To inhale it, is it?
Well, no,
Okay.
you don't inhale it. I don't think you would be able
No,
to
not
inhale it.
me. I mean the little pipette.
Yeah, no, don't do that.
I'm trying to turkey baste it.
And so what we're trying to get is some carbon dioxide in the bottom of the pipette. And the more you get, the more fun this is going to be.
Well, then I want lots.
So the idea here is we're going to make this into a sealed container. If you've ever seen CO2 fire extinguishers, inside that canister is liquid carbon dioxide and a little bit of gas space over the top. That's what we're going to try to do here. How much you got in there? Let me see.
A little bit.
That looks pretty good.
Okay.
All right. So here's the technique. What we're going to do, we've got little containers of water. We'll do 2 of them side by side. We're going to do, this is tricky, so you're going to take the pair of pliers, you're going to squeeze the top, and then you're just going to rotate it, and kind of bend it over. Like I said, it's tricky. And then you're going to seal it up at the top.
Okay.
And you got that? You might have to do a couple twists, because we really want a really good seal. We're going to attempt to build up like 5.1 atmospheres of pressure inside this little plastic thing.
Oh, all right.
So you got it?
While I'm messing with this, we want to remind you, you can come on down to the Imagination Station, step inside the think tank. It is here, and it is open on Saturdays. And if you live in Lucas County, and you have a kid who lives in Lucas County, and you have a paid adult admission, that kid can actually get into the Imagination Station today for free. Carl, I'm having a little trouble here.
That's okay. I think I may have gotten mine.
Okay.
You're going to do the same thing, though. What I want you to do is we're going to lower this into the water. I don't know if the camera can get a really close shot of what happens inside here. If you can't get it, that's okay.
Okay, all right.
You got.
Doing my best.
That's good. So you dip this into the water. We got carbon dioxide that's solid down in the bottom of the bulb, but as we build up pressure, that solid is going to change into a liquid. If we have it tight enough, see, I think mine's doing it. Check out mine. It's turning into a liquid.
Wow!
Whoa! and it builds up that 5 atmospheres of pressure. It bursts. And when it bursts, it turns back into solid carbon dioxide.
Yeah, it did.
Pretty cool, huh? You're going to they took dry ice, put them in those pipettes, and then if you watch the video, you can see that pipette start to bulge out because that pressure is increasing. And that's what causes it to liquefy. This is a graph of carbon dioxide. Here you can see this is our line from solid to gas. And you've all played with dry ice at Halloween or some other time where you know that it sits there and it changes to a gas right in front of you. If you put it in water, the water vapor will get caught up in that gas and you can see it coming off as looks like a smoke from a fire or something. So if you're at 1 atmosphere, the temperature, the point at which at 1 atmosphere, we're never going to get to a liquid with carbon dioxide. We're only going to ever go from a solid to a gas. In order to get to a liquid, we have to heat it up to 5.1 atmospheres. And so this diagram shows you carbon dioxide. Iodine's another one. Iodine is a solid at room temperature. But iodine can change to a gas very easily. It doesn't become a liquid real easily. I have some iodine in the classroom that I had for a demonstration I did when I taught Gen Chem a few years back, and it's in a sealed bottle. but the whole bottle is purple because the little grains of iodine have changed and deposited on the sides of the bottle. Here's 1 atmosphere, and you can see that at 1 atmosphere, the gas, we can go between a gas and a liquid fairly easily at 1 atmosphere if it's 184 degrees. What temperature is room temperature? Well, 100 degrees Celsius is boiling, so it's definitely not that. It's about 31. So you can see you're going to, at that point, at 1 atmosphere and at room temperature, you should have a solid. But you could heat it up enough that it will go back and forth between a solid and a gas. Now, the worksheet, or the online stuff, is kind of cool. It has an interactive window here, and if I put and this is carbon dioxide, when I put my cursor up here, you can see that all the particles are in solid mode. If I put my cursor on that line between 0, which is the triple point, and D, you can see that it will melt. If we put it up here on the line between liquid and gas, you can see it vaporizing, becoming a gas. If we come up here to the superfluid part, you can see that it's moving fast. So on and so forth. So that's kind of cool, and you can work on that as you go through these problems. They're not very difficult. You just have to be able to read them. Okay? So that is triple point and phase diagrams. That there will be a question on that on the final. All right. Thank you very much.